Okay, I hope I'm audible to all the students who are attending this lecture. We start with a new topic in class 12th mathematics. This is called differential equations. It's a very interesting topic in mathematics. Okay, so and it is again an application of integrals. Okay, so one application of integrals which we had done in the previous lectures was to find the area under the curve. Okay, this is another application of integrals which is differential equations. Okay, so first of all, let's understand what is meant by a differential equation. So let's write the definition. An equation involving derivative or derivatives of the dependent variable, an equation involving the derivative or derivatives of the dependent variable with respect to the independent variable or plural variables, okay, is called a differential equation. It is called a differential equation. So an equation which consists of derivative of the dependent variable with respect to the independent variable is called a differential equation. So for example, suppose I say, suppose y is a function of x, where all of us know that x is the independent variable. X is the independent variable, and you can see y is dependent on x. So y is the dependent variable. Okay. Then consider the equation. X into dy by dx plus y equal to 0. Okay, this is called a differential equation. This is called a differential equation. Why? Because you can see that this equation consists of derivative of the dependent variable with respect to the independent variable. What is the derivative, guys? The derivative is nothing but dy by dx. So you can clearly see that this equation consists of dy by dx, hence it is called a differential equation. Okay, another example would be, so I can write another example. So another example of a differential equation is 2 times d square y by dx square plus dy by dx ka cube equal to 0. You can again see that the equation consists of derivative of the dependent variable with respect to the independent variable, that is dy by dx. So both these are examples of differential equations. So I quickly revise. An equation is said to be a differential equation if it consists of derivative of the dependent variable, which in our example is y, with respect to the independent variable, which is x. That means if the equation is written in terms of dy by dx or higher powers of it, then that equation is called a differential equation. Okay, so we can move forward and let's write one more definition. What is called an ordinary differential equation? So ordinary differential equation. Okay, so let's understand what is meant by ordinary differential equation. So a differential equation, involving derivatives of the dependent variable, a differential equation involving derivatives of the dependent variable with respect to only one independent variable, is called an ordinary differential equation. Is called an ordinary differential equation. Okay, so if we consider a differential equation which consists of derivatives of the dependent variable with respect to only one independent variable, that means you are differentiating the dependent variable with respect to only one independent variable, not many independent variables. So such an equation is called an ordinary differential equation. Example, guys, the equation which I just wrote a few minutes back, 2 times d square y by dx square plus dy by dx cube equal to 0 is an ordinary differential equation. Why is it an ordinary differential equation? Because you can see that the equation consists of derivative of y only with respect to x. We are not differentiating with respect to more than one variable. We are differentiating only with respect to one variable. So since we are finding the derivative, the equation consists of derivative of y only with respect to x, hence it is an ordinary differential equation. Okay, then all students should be familiar with the notations which we will be continuously using for derivatives. So let's write the notation used for derivatives. So when we are studying differential equations for higher order derivatives, writing d square y by dx square, d cube y by dx cube becomes a bit complex. So we can write it like this. So dy by dx we denote by y dash. Okay, d square y by dx square we denote by y double dash. D cube y by dx cube we denote by y triple dash. Okay, and in general I can write dny by dxn, we write y to the power n, or not y to the power n, y subscript n. Y subscript n means you are finding out dny by dxn. So all students should be familiar with these notations. Okay, dy, whenever we write dy by dx, easily we can write it as y dash. D square y by dx square we can write as y double dash. D cube y by dx cube we can write as y triple dash, and so on. Now let's understand the concept of order of a differential equation. So after we have understood what is a differential equation, what are ordinary differential equations, now let us look at order of a differential equation. Okay, So let's look at order of a differential equation. So let's look at the definition. The order of a differential equation. The order of a differential equation is defined as the order of the highest order derivative. Order of the highest order derivative of the dependent variable which in our example is y, with respect to the independent variable, which in our lectures is variable x, involved in the differential equation. So guys, this is the definition of order. Order of a differential equation is given by the order of the highest order derivative of the dependent variable with respect to the independent variable involved in the differential equation. Okay, so basically you will be given the differential equation. You need to see what is the highest order derivative which is there in the equation. The highest order derivative will give you the order of the differential equation. So let's look at the question. For example, suppose I am given three differential equations. This is one differential equation, dy by dx is equal to e to the power x. Okay, this you can see it's a differential equation. Why? Because it consists of derivative of y with respect to x. Another differential equation, d square y by dx square plus y equal to 0. Another differential equation, d cube y by dx cube plus x square times d square y by dx square ka cube equal to 0. Now guys, can we find the order of these three differential equations? So let's find the order. Let's find the order of these differential equations. So guys, look at the first equation. If you look at the first equation, look at dy by dx. This is of what order? This is of order 1. It's a first order derivative. So what will be the order of this differential equation? The order of this differential equation is 1. Okay. The order of this differential equation is 1 because it consists of first order derivative. The highest order of the derivative is 1. Look at the second differential equation. What is the derivative? D square y by dx square. What is the order? 2. Highest order is 2. And look at the third differential equation. Look at dy by dx. It's coming as d cube y by dx cube. Now d cube y by dx cube, highest order is 3. So order of the differential equation is 3. So basically you need to look at the derivative. The highest order of the derivative will be the order of the differential equation. So first equation, what is the highest order of the derivative? 1. So what is the order of the differential equation? 1. Second equation, what is the highest order of the derivative? 2. So what is the order of the differential equation? 2. Third equation, what is the highest order of the derivative? 3. So what is the order of the differential equation? 3. So I hope all students have understood the concept of order of a differential equation. Now let us talk about degree of a differential equation. Okay, so let's understand the concept of degree. We have done order, now we talk about degree. So degree of a differential equation. Okay, so very important point to understand first before we move on to the definition. To find the degree, of a differential equation, the differential equation must be a polynomial. The differential equation must be a polynomial equation in the derivatives. That is, guys, what are my derivatives? Y dash, y double dash, y triple dash, etc. That means you can find the degree of a differential equation only if the differential equation is a polynomial in the derivatives. Okay, if your differential equation is not a polynomial in the derivatives, you cannot find the degree. For example, let's consider the differential equations. For example, I am writing a few differential equations on the screen. D cube y by dx cube plus 2 times d square y by dx square ka square minus dy by dx plus y equal to 0. Look at another equation, dy by dx ka square plus dy by dx minus sine square y equal to 0. And third equation, dy by dx plus sine of dy by dx equal to 0. Now there are three differential equations. Let us see, can we find their degree or not? So to find the degree, the derivative should be in the form of a polynomial equation. Now guys, first of all, you should understand what are polynomial equations. If I write a polynomial equation for you, I'm writing it on the top. So a polynomial equation in general is an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 plus dot 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 a1 x plus a0, where a0 is a constant. This is a general polynomial of degree n. This is a general polynomial of degree n. Okay, now the only difference is in differential equations, instead of x being the polynomial, dy by dx should be a polynomial. That means the derivative should be a polynomial. That means it can be in the form of powers. So you can see, look at the first equation. Look at the first equation. You can clearly see that it's a polynomial. The derivatives are in terms of polynomials. Okay, so if you look at this equation, the first equation, so the first equation is a polynomial. This is a polynomial in d cube y by dx cube is y triple dash, d square y by dx square is y double dash, and dy by dx is y dash. So it's a polynomial in y triple dash, y double dash, and y dash. That means you can find the degree. The second equation is a polynomial in y dash, because you can see we have dy by dx here also, dy by dx here also. So it's a polynomial in y dash. Even though it's not a polynomial in y, so understand this, even though the second equation is not a polynomial in y, but it is a polynomial in y dash. Look at the second equation, guys. even though it is not a polynomial in y, because we are having sine square y. It's not a polynomial in y, but it is a polynomial in y dash. So we can find the degree of the differential equation. But now look at the third. Look at the third equation. Is not a polynomial. It is not a polynomial in y dash. dy by dx is y dash. It is not a polynomial in y dash. Therefore, we cannot find the degree of the third differential equation. We cannot find the degree of the third differential equation. Why? Because it consists of sine of dy by dx. That means dy by dx is not coming up as a polynomial. So the purpose for taking the example is to explain all of you first, in which case can we find the degree. What is degree? I haven't discussed it. What is the degree of a differential equation is still to be discussed. I am first discussing with you when can you find the degree and when you cannot find the degree. So all students should remember, you can find the degree of a differential equation only if it is a polynomial equation in derivatives. It may or it may not be polynomial in x and y, but it has to be polynomial in the derivatives. So you can see the first equation is a polynomial in y triple dash, y double dash, and y dash. Second equation is also a polynomial in y dash, even though it is not a polynomial in y. But the third equation is not a polynomial in y dash because of the term sine of dy by dx. That means you can find the degree for the first two differential equations, but you cannot find the degree for the third differential equation. So I hope all students should be clear with this. Now let's move on to the definition. So degree of the differential equation, and I am now writing the definition. So let's quickly write the definition. By the degree of a differential equation, we mean the highest power. We mean the highest power of the highest order derivative. Highest power of the highest order derivative involved in the given differential equation. Involved in the given differential equation. So by the degree of differential equation, we mean the highest power of the highest order derivative. That means in the equation, you look for the highest order derivative. What is its highest power? So that will give you the degree of the differential equation. But guys, again, you should remember the main condition. You can find the degree only if the equation is a polynomial in derivatives. If the differential equation is not a polynomial in derivatives, you cannot find the degree of a differential equation. So first of all, it should be a polynomial in the derivatives. Then you find the degree. How do you find the degree? Look at the highest order derivative. And among the highest order derivative, look at the highest power. That highest power is called the degree of the differential equation. So can we find the degree? So I am giving you the differential equations and let's work out their degree. So you can see I am taking the same differential equations which I just took a minute back. So So these are the differential equations given to us, and we are finding their degree. Degree of the differential equations. Okay, so you can see the first differential equation is d cube y by dx cube plus 2 times d square y by dx square cos square minus dy by dx plus y equal to 0. Now guys, this is the differential equation given to you. Look at, you can clearly see it's a polynomial in the derivative, so that means you can find the degree. Now the second thing, look at the highest order derivative. Highest order derivative is, what is the highest order derivative here? D cube y by dx cube. What is the power of d cube y by dx cube? It's d cube y by dx cube whole raised to the power 1, so the degree of the differential equation is 1. D cube y by dx cube is the order. It is raised to what power? 1. So the degree of the differential equation is 1. Okay. Similarly, let's consider the second differential equation, dy by dx cos square plus dy by dx minus sine square y equal to 0. Again, can you find the degree of this differential equation? Yes. Why? Because even though it's not a polynomial in y, it is a polynomial in dy by dx. So you can find the degree. Now, how do you find the degree? Look at the highest order derivative. Highest order derivative is dy by dx. Now, what is the highest power of dy by dx? Highest power of dy by dx here is 2, because dy by dx is raised to the power 2. So the degree of this differential equation is 2. Guys, it's very simple. To find the degree, you look at the highest order derivative and then look at its highest power. What is the highest order derivative in the second equation? Dy by dx. What is its highest power? 2. So what is the degree? 2. Okay. And similarly, third equation, dy by dx plus sine of dy by dx equal to 0. Now this is the differential equation given to you. Let us find the degree. Can you find the degree? No. Why? Because dy by dx is not coming in polynomial terms. The third equation, which you can see on your screens, is not a polynomial in dy by dx. Since it is not a polynomial, so I can write, since this equation is not a polynomial in dy by dx, hence the degree of this equation is not defined. Degree of this equation is not defined. So I hope that students have understood this. Okay. Then we can do one more question. So let's do one more practice question on both the order and degree. So let's look at this practice question. Find the order and the degree if defined. Order will always be defined, but degree may or may not be defined. Find the order and degree if defined for the following differential equations. For the following differential equations. So guys, I'm making a table and I'm giving you some differential equations. Let's find their order and degree. Okay, so these are the differential equations given to us. Differential equations. Okay, and we have the order here and we have the degree here. So let's look at the equation. So first equation is dy by dx minus cos x equal to 0. Now guys, how will I find the degree? What is the highest order derivative? Dy by dx. It is of order 1. So the order of the differential equation is 1. Highest order derivative is dy by dx. And what is the order of it? 1. So order of the differential equation is 1. What will be the degree, guys? First of all, is it a polynomial in dy by dx? Yes. You can clearly see, even though it's not a polynomial in x, it is a polynomial in dy by dx. So what is the highest order derivative dy by dx? It is raised to the power 1. So degree of the differential equation is also 1. Because highest order derivative is dy by dx in this equation and it is raised to the power 1. Similarly, let's look at the second equation. Xy into d square y by dx square plus x into dy by dx ka square minus y into dy by dx equal to 0. So guys, what will be the order of this differential equation? You can clearly see that in this differential equation, the highest order derivative is d square y by dx square. The highest order derivative is d square y by dx square. It is of order 2. So the order of the differential equation is 2. And now let's look at the degree. Is it a polynomial in derivatives? Yes. You can clearly see it's a polynomial in y double dash and y dash. So we can find the degree. How will you find the degree? Look at the highest order derivative. What is the highest order derivative? D square y by dx square. What is the power of it? 1. So what will be the degree? Degree of this will be 1. And similarly, guys, we can look at the third differential equation. Y triple dash. Let me write it more clearly. This is y triple dash plus y square plus e to the power y dash is equal to 0. Now guys, y triple dash, you should know y triple dash is nothing but d cube y by dx cube and y dash is nothing but dy by dx. So can we find the order? What is the highest order derivative? Y triple dash. What is the order? 3. So what is the order of the differential equation? 3. Can we find the degree? No. Why? Because you can see the third equation is not a polynomial in the derivatives. It consists of the term e to the power y dash, e to the power dy by dx. So I can say this equation is not a polynomial. This equation is not a polynomial in derivatives. Therefore, thus degree is not defined. Since it is not a polynomial in the derivatives, hence the degree of this polynomial is not defined. So I hope all students have understood this question. Okay, and then we can quickly look at the exercise 9.1. Okay, so let's quickly look at exercise 9.1. Although students have understood the concept, so a lot of questions I am giving you for homework, but some of the questions I intend to solve. So exercise 9.1 of NCRT based on the order and degree of differential equations. So guys, again, I am doing with you some of the questions remaining to be done by you at home. So again, we are given some differential equations. So the question is, find the order and degree if defined for the following differential equations. Find the order and degree if defined for the following differential equations. So as you all can see on your screens, differential equation, order and degree. I'm making again a table, differential equations, order and degree. So here I am writing the differential equation. Here we talk about its order and here we talk about its degree. So guys, from this exercise, I'm doing question 6. Y triple dash ka square plus y double dash cube plus y dash to the power 4 plus y to the power 5 equal to 0. So you can clearly see it's a differential equation. Now guys, what will the order of this differential equation be? What is the highest order derivative? Y triple dash. What is the order of that? 3. So what is the order of the differential equation? 3. Okay. So order of the differential equation is 3. To find the degree, is it a polynomial in derivatives? Yes. You can clearly see that this differential equation is a polynomial in derivatives. How do you find the degree? Look at the highest order derivative. It's y triple dash. What is its highest power? The highest power of y triple dash coming in the equation is 2. That means what is the degree of this differential equation? 2. Okay. Similarly, I can do with you another question. Question 9. Okay. Y double dash plus y dash ka square plus 2y equal to 0. How do you find the order? Highest order derivative is 2. Order is 2, so order of the differential equation is 2. How do you find the degree? Is it a polynomial in derivatives? Yes, so you can find the degree. What is the highest order derivative? Y double dash. Y double dash is raised to the power 1. So what is the degree of this differential equation? 1. So I hope all students have understood this. And guys, all the remaining questions are for homework. Okay. So homework for this lecture, exercise 9.1, all questions except the ones which I have done in this lecture, which is question 6 and question 9. Except for question 6 and 9, all questions of the exercise 9.1 are for homework. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mics and ask, or call up or mail me your doubts at divineschoolofeconomics@gmail.com. So this is where I stop.